Today we are working on solving equations with special cases, and so we're actually only going to work out one of each type together today, and then there are 6 on the back of your note sheet that you'll work out independently. So let's get started on the first one. So if we have 3 and in parentheses 2x plus 4, close parentheses, is equal to 6 and in parentheses 5x plus 2, close parentheses, then we know that we need to distribute our 3 to both of the terms in the parentheses. And also we're going to have to distribute on the other side of the equation as well. So the 6 will go to the 5x and also to the 2. So 3 times 2x will give us 6x. And 3 times a positive 4 will give us a positive 12. And that is equal to 6 times 5x is 30x. And 6 times a positive 2 is positive 12. So to solve the equation, when we have variables on both sides, there are several different methods you can use. So I always like to start with moving my variables first, and I usually like to move them to the left side of the equation. So in this case, I'm going to subtract 30x. But remember that there are several different ways that you can solve this equation, and still you should get the same answer. So if I subtract 30x from both sides of the equation, 6x minus 30x would give us negative 24x plus 12 is equal to, and on this side we're left with the positive 12. So then I would need to move this positive 12 to the other side, so I'm going to subtract 12. And I would have negative 24x is equal to 12 minus 12 would give me 0. So then to get x by itself, I would need to divide by negative 24 and divide by negative 24. And so x would then equal, so 0 divided by negative 24, so x would equal 0. And so in this case, x is a specific number. So 0 is a number, so we have an equation that has one solution, whether that be 0, 1, 2, 3, whatever, there's just one number that will work to make this equation true. So let's look at another one. So if we have 6 and in parentheses g plus 2 equals 4g plus 7 plus 2g. So we're going to have to distribute on this side of the equation. So we'll distribute to the g and to the 2. So 6 times g is 6g. And 6 times 2 is a positive 12. And on this side of the equation, I have some like terms that I can combine. So I have 4g and a positive 2g. So that would give me 6g. And then I still have plus 7. So like usual, I like to move my variables to the left side. So I'm going to subtract 6g, and I'm going to subtract 6g on this side. And so my g's cancel, so I have 12 equals, and 6g minus 6g over here, so those g's also cancel, so then I end up with just 7. And then we should recognize that, well, 12 doesn't equal 7, so they're actually not equal. And so what this means is that it has no solution. So there is no solution or no value of x that would make this equation true. And so I'm going to point out something else that you may see, that we also up here had 6g plus 12 equals 6g plus 7. And so up here even you can see that the 6g is the same on both sides, and yet you're going to end up with 12 on one side and 7 on the other. So you may end up seeing that ahead of time before you actually manipulate the variables. And so our solution would be that there is no solution. And last one. So if we have 4m minus 1 equals 2, and in parentheses 2m minus 3, close parentheses, plus 5. So this side of the equation is as simplified as it can get. So 4m minus 1 will come down. And then I'm going to distribute. So 2 times 2m is 4m. And 2 times a negative 3 is negative 6. And then I'm going to bring down that positive 5. So remembering that the 2 does not get distributed to that positive 5 because it's not in the parentheses. So still nothing to do with the left side yet, so I'll just bring that down. So 4m minus 1 is equal to, and I can combine the negative 6 and the positive 5. So I'm going to bring down my 4m. And negative 6 plus 5 gives us a negative 1. So I'm going to move my variable. So I'm going to subtract 4m and subtract 4m. And then I'm left with, so my variables are going to cancel, so I'm left with negative 1 is equal to, and those variables eliminate, so negative 1 is equal to negative 1. And in this case, that is a true statement. Negative 1 does equal negative 1. So the solution to that, what we would write, is that there are infinitely many solutions or all real numbers. So a couple of different situations, and you can also, similar to the one prior, you can see that up here 6g plus 12 equals 6g plus 7, so your value for the variables or the coefficient of the variables was the same, but your constants were different, so that ended up to be no solution. But here we can see that we have 4m minus 1 equals 4m minus 1, so you can actually see that they're equal all the way up here. So it just kind of depends on how early you can recognize what type of solution you're going to have. So we have obviously worked with equations with one solution frequently, but you're also going to encounter some equations with no solution as well as equations with infinitely many solutions. So make sure you take good notes and keep track of the steps and how you write your solution, if there is one, as your response. There are 6 on the back side of your notes sheet that I want you to practice on your own, and when you are finished with those, I will have you verify your answers with my answer key. And so the video is finished, so you can stop the video and just work on those problems on the back side.